frustrating. Our report is next week and we even haven't practiced yet.
We should start now. I believe Ali is coming.
I'm hearing my name, and yes, I am here. Where's Kate? She would be here by now.
Hey, I'm here now.
Finally, we're complete.
I'm literally here,
Have you always been there?
I've been here ever since the call started. I even came before you.
Okay, that's enough. Let's start, please. Alexis, you'll be the one to start the presentation.
Yeah, wait up. Let me share my screen so that everyone can see it. There we go. So, here goes. Hey everyone, we are Group 3 and we are here to bring you information about the sedimentary and phosphorus cycle. And as our title goes, Layers of Time, Unearthing the History of the Earth's Soil over Time. First of all, what are the sedimentary and phosphorus cycles? The phosphorus cycle is a type of sedimentary cycle that involves the movement of phosphorus in various forms of nature, such as the lithosphere, hydrosphere, and biosphere. But before continuing our discussion, what is phosphorus? Phosphorus is an essential nutrient for sustaining life on Earth, where it plays a central role in the transfer of energy within organisms, the structure of the genetic material, and in the composition of cell membranes, bones, and teeth. Out of all the elements recycled in the biosphere, phosphorus is the most scarce, and hence the most restricted element in any particular ecosystem. So back to our main discussion. How is phosphorus recycled in our environment? Kiara will discuss this. Kiara?
Thank you, Danielle. So, how does the phosphorus cycle work? It all starts with weathering. Since the reservoir, or the main source of phosphorus, is found on rocks, which are located in the Earth's crust, phosphorus is extracted from those through weather events, like rain or other sources of erosion. Then, once phosphorus is extracted and goes into the soil or washed into the local water systems, the plants, fungi, and microorganisms absorb the phosphorus and grow. Additionally, phosphorus is also obtained by animals from drinking water and eating plants. Afterward, when the plants and animals that acquired phosphorus die, the phosphorus returns to the environment due to decomposition. Then, the phosphorus from the dead organisms can be obtained once again by plants and animals, and then the cycle repeats. However, what happens if invasive species are put in the ecosystem? How does it affect the phosphorus cycle? This will be discussed by Alysa. You may now take over, Ally.
Thank you, Kiara. Now we'll be talking about invasive species and how this affects phosphorus cycle. But first of all, what are invasive species? According to the United States Geological Survey, an invasive species is an introduced non-native organism that spreads or widens its range from the location of its introduction and has the potential to affect environment, the economy, or human health. So, how do invasive species affect the phosphorus cycle? In an experiment by Fong Sang and others in 2022, they studied how an invasive plant species can disrupt soil functioning, particularly the phosphorus cycle. Compared to native plant species, they found out that invasive plants can enhance organic phosphorus decomposition through microfungal interaction, and they might also have higher phosphorus utilization efficiency compared to native ones. Another study by Jiang Li and team in 2021 studied how destined mussels, significantly fibra and guaga mussels, affect the phosphorus cycle in the Great Lakes. Their findings demonstrate that even the largest aquatic ecosystem in the world, a single invasive species, can have a significant impact on the biogeochemical cycle. Now that we have talked about the effects of invasive species on phosphorus cycle, let us now look at its anthropogenic effects, which will be discussed by Kathleen. Take the spotlight, Kath.
Thank you, Ali. For this segment, we will now be talking about the anthropogenic effects on the phosphorus cycle. To put it simply, how do we humans affect the phosphorus cycle? Human activities such as agriculture and wastewater treatment can greatly impact the phosphorus cycle. Fertilizers, for instance, can add a significant quantity of phosphorus to the soil, which can later leak into the groundwater or flow into nearby bodies of water. While fertilizers are used to increase the productivity of crops, their phosphorus excesses can cause environmental issues like eutrophication, which refers to the natural process in water bodies wherein there is an increase in the production of algae and macrophytes, which not only makes its quality deteriorate and dissolves its oxygen, but can also become toxic to the plants and animals in the ecosystem when those algae die and form algal blooms. Hence, such human activities serve to harm ecosystems due to the excess amounts of phosphorus.
You have now finished discussing what are phosphorus and sedimentary cycles, their processes, and how invasive species and humans affect them. However, what is the current status of phosphorus? As it was mentioned by Alexis earlier, phosphorus is the most scarce of all elements that can be recycled on our planet and is being depleted at an alarming rate. Ultimately, we will exhaust all known phosphorus reserves in around 80 years if we continue with our current usage. But this will not continue forever. Hence, without the proper measures of using and reducing our inflating usage of it, the world will be in a dire situation of growing crops for food supply. That is all for our presentation. This is our references, and to summarize the discussion, let me call on Kathleen. Kathleen, are you there?
Thank you, Danny. To sum up everything that has been mentioned earlier, phosphorus is a crucial element in our ecosystem as it is an essential nutrient for growing crops and keeping the system balanced. In our presentation, we demonstrated how the phosphorus cycle works and how invasive species can be a hindrance to the phosphorus cycle. Furthermore, we also explained how we humans contribute to the depletion of phosphorus in our ecosystem. However, despite that, we have the power to maintain a healthy phosphorus cycle by simply reducing our usage of phosphorus and by informing other individuals such as our friends and family. These do not only help us and our environment, but they also significantly contribute to the betterment of the future of our world. This marks the end of our presentation. We hope you learned something new about the phosphorus and sedimentary cycles and what actions we can take in order to maintain the functions of those said cycles. Once again, we are Group 3. Thank you very much for listening and goodbye.
And that's a wrap. Good job, guys.
It was nerve-wracking. Do you think we can present this to the class next week?
That would be a piece of cake. Well, for me it is.
Show off.
What you say?
Okay, that's enough, both of you. Make sure not to do that next week of our presentation, got it?
Tell that to her.
That's enough. Let's wrap this up, guys. I'll see you all next week.
Alright, bye guys!
Bye! Good luck to all of us!
Bye!
Bye. And Kiara, I hate you.
Kids.